Okay, so in this video we're going to have a look at the derivation of the amortisation formula. This is a question that has come up a couple of times in the last few years, so it's always good to know. Most of it now you'll be able to kind of work through yourself, but it's the last maybe 2 to 3 lines that'll just need a little bit of practice. So a mortgage of P is taken out and is to be repaid over T years, with equal repayments of A being made at the end of each year. The APR expressed in decimal form is I. Derive an expression for the payment amount A in terms of P, I and T. Okay, so what happens here is, because it's a repayment, we know it's going to be P is equal to F over 1 plus I to the power of T. And then P is going to be the principal. So that's the mortgage amount. And then we have F will be the A repayments, whatever they add up to. I is going to be the interest. And then T is equal to the time. So the length of the loan. So another way to look at that maybe is number of repayments. Okay, so what we'll do is we'll set it up as if we had a normal loan question that we were working on, and just instead of F we use the letter A. So we'd have A over 1 plus I to the power of 1 plus A over 1 plus I squared. So we'd have established our pattern there and so on. And I'd finish off as A over 1 plus I to the power of T. So T would be however many years. Then we know we have our sum to end formula. So we're just going through the process as usual, except this time we have letters instead of numbers, that's all. So our initial is A over 1 plus I. It changes each time by 1 over 1 plus the interest rate. And then N, for that we always put in T. Okay, so for sum to N, we know it's the principal, so we get P is equal to A over 1 plus I on, and this is where your brackets are important, just to keep it nice and neat, 1 minus or to the power of N all over 1 minus or. Okay, so our goal, because we've been asked to derive an expression for the payment amount A, we need to rearrange this formula so we have A is equal to, so we'll cross multiply by the bottom, so then we get P on 1 minus 1 over 1 plus I, and then that's all going to be divided by this square bracket. So we have 1 minus 1 over 1 plus I to the power of T will equal A over 1 plus I. Again, we're not quite there, we need A by itself. So we get A is equal to P times, and then the 1 plus I comes across, and our square bracket stays as is, and then the denominator has stayed as it is. So we get 1 minus 1 over 1 plus I to the power of T. Okay, so what's happened now is we've isolated A, but it's not quite in the format of amortisation formula. So your amortisation formula is in your log tables, and it tells you A is equal to P times I 1 plus I to the power of T all over 1 plus I to the power of T minus 1. So just in terms of that formula to compare, we have P, we have a 1 maybe plus I, but it's not to a power, and we're missing that I by itself. And if we look at the bottom here, it's just not quite in the right order. So that tells us we've a little bit of manipulation to do to get it into that format. So we'll look at the top and the bottom and tidy those up. So if I look at my top line, I have 2 brackets. We're going to multiply them. So the P stays where it is, So we have p on 1 plus I by 1 will give me 1 plus I, and then 1 plus I, the sign will be minus 1 plus I by 1 over 1 plus I will give me same thing on the top and the bottom. So now looking at that, I know it's going to cancel to 1. So that'll be a little bit of tidying up. And then here we have 1 minus, and we'll deal with this power. So that becomes 1 to the power of t over 1 plus I to the power of t. Now, 1 to the power of anything will always just give us back 1. So that'll let us tidy up that line a little bit. So we get A is equal to P on 1 plus I. And then like we said, that bracket will just become 1. And then all over 1 minus 1 over 1 plus I to the power of t. Okay, so we've got a little bit further. We're just not quite where we need it to be. So we have a look at the denominator because we have a bit of work to do there. So we need an LCD, and that's going to be 1 plus I to the power of t. So now we tidy that up. A is equal to, we'll leave the top line as is for now. So that's 1 plus I minus 1. And for the bottom line, so it'll be 1 multiplied by 1 plus I to the power of t minus 1 all over 1 plus I to the power of t. Top line has a bit of tidying up. We've plus 1 minus 1 will just give me I, so that's p multiplied by I. And then for the bottom line, we have 1 plus I to the power of t minus 1 all over 1 plus I to the power of t. So we know we don't divide a fraction by a fraction. What we do instead is flip and multiply. So that's p by I multiplied by 1 plus I to the power of t all over 1 plus I to the power of t minus 1. And then that line now we just tidy up and we get A. So top by top we have P, we have I, and we have 1 plus I to the power of t all over 1 plus I to the power of t minus 1. So I've isolated A by itself, and if we compare the formulas, Pi times 1 plus I to the power of t, check our top line, Pi 1 plus I to the power of t, and our bottom line is 1 plus I to the power of t minus 1. If we have a look up on top, it's the same. So there's our answer, and that's how you derive the formula or prove the formula for amortization. And that's us done.